Hello engineers, thank you and welcome to today's class. Today we are going to look at integration, majorly on integration by parts. So this is the formula we use, whereby we are given integral of u dv is equals to uv minus integral of v du. So just mastering this formula, and know how to apply and know how to categorize u, v, how to find the u and how to find the v, then you'll be good to go. So here are the notes to make concerning integration. If let's say we have a polynomial which is a logarithm, which is in a logarithm form, that's like ln of x. Now this is a method of determining the value of u and v, so they are not the same way. So let's say we are given x square ln of x, so this one is shown up when a polynomial is a log function. So you have to decide the u and v, and will not be the same as when the polynomial is maybe a trigonometric. So when you are given the polynomial as a trigonometric function, this will not be the same way as locating the u and v in the equation. So the given example, x sine 3x. So another one is when the polynomial is an exponential. So when the polynomial is an exponential, x, for example, u, locating u and v. So given an example, x exponential x square exponential x 2x dx, then dx, because to indicate they are being integrated. So there are different ways. As per these three equations, there are different ways of considering u and v. So for the first, when the polynomial function here is a logarithm, you will have u as ln of x. So most engineers have the tendency of choosing x square as our u, but in this function you let ln of x be your u, so and x square be the dv, so our dv will be x square. Then you just replace as you can see in this equation. So we don't have the du, we don't have the v and du. So to find the dv, you have to integrate. To integrate dv, you can get v. So integrating v, integrate also its function there. So v, integrating the v, you can have v, then integrate x square, you'll have 1 over 3 x square. So you have the value of v. Now the value of du, because we don't have the d and we have u, so we have u is equals to ln of x. So to get du, we differentiate du to get the value of du. So du over dx, we have 1 over x. So differentiating du over dx, we get 1 over x. So and we want the du, so du multiplying by the denominator, we have du is equals to dx over x. So now we have all the required functions here. So coming to integrate, you just replace them directly. So let's go to example b. So in example b, x sine 3x when the polynomials are trigonometry. So locating the u and v. So here we just apply the same method to exponential when the polynomial is an exponential, whereby x, we start directly with x, our u will have as x, then our v will have as sine 3x. It's just the same way as the exponential equation. So here our dv will have sine 3x. So now we are going to look for the missing, which is v and the du. So integrating dv to get v, will have v integrating sine 3x will have negative 1 over 3 cos 3x. So this one will be the integral, that will be v. This is the value of v. Now we are now looking for only du. So we have our u there as x. So to get du, we have du over dx will be 1 and differentiated. So du across the equal sign multiplying by the method, du is equals to 1 dx, which is dx there. So here we have all the function and we replace them directly, and use the same also in when the polynomial is an exponential function. So let's look at an example. Looking at an example number 1, when exponential is a logarithm, we have